project, we used VBA to do clash detection on a multitude of models, and by doing that we solved like hundreds of conflicts, probably over thousands of potential conflicts. But one of the main ones was definitely when we used it to help coordinate the underground conduit for the electrical model and coordinate that with the substructural model, and that involved getting the electrical designer involved with the structural engineer as well as the structural concrete subcontractor to kind of figure out what was the best way to help route these conduits. And one of the main challenges during that discussion was really just to figure out how can we minimize the amount of excavation to dig for the conduits, also to minimize the amount of bends, because the conduits are only allowed to bend a certain amount of 90s by code, and also just to figure out, we really wanted to minimize the amount of these dropped footings for the columns. If the conduits had to go over a column footing, we really wanted to minimize the amount of footings that had to be dropped for that. So if we could avoid those footings at all costs, we tried to, but some cases like this one, you can see there's a clash there, so this one probably dropped. But anyways, I just wanted to show you a lot of the typical issues we had during that coordination process. So just to show you some of these typical clashes, there's that one I just looked at. Here's a series of clashes throughout the column footings. Here you can see all these conduits that are in the slab where they're going to be clashing with these footings. You can see that all these conduits coming down into this garage right here. This is a lot of wasted run. When we can minimize the amount of this conduit going down, we took it all the way up here and had it come in to the garage through a drop soffit. Here you can see it's clashing with the wall footings. Some more footings right there. A lot of conduits are coming in at the wrong height. We just want to make sure those are, properly modeled so we can properly see where the potential problems were. Some more footing conflicts. And there's another one. So that was the before. Here's the after. After we've resolved all those conflicts, I just want to kind of give you a little tour of the model after we resolve those issues. So for instance, here's a drop footing where we needed to drop in order to avoid that conflict. So we really wanted to minimize the amount of footings that had to drop, just because it's just more costly to excavate that. But you can see that there's that series of clashes we saw earlier running across. So these footings are dropped. You can see there. And then that one we saw earlier where a lot of excavation was going to need to be done if the conduits were at that height. You can see that is tucked up high and tight up against the slab here. And there it is coming into the building. And there it is with the drop soffit. So let's go back in. So you can kind of see how we, just by doing the coordination, how much time and material and labor we basically saved to really help the owner, help just mitigate the amount of RFIs and costly change orders that would have most likely occurred if these weren't coordinated properly.